Hello, and welcome to this webcast on Geographic Calculator. I'm Jasmine Bird, an Application Support Specialist for Blue Marble Geographics, and I'm here with Sam Knight, the Director of Product Management.
Hello everyone. Today's topic is going to involve Geographic Calculator version 2015 Service Pack 1, and today we're going to be working with seismic data. We're going to be working through three main interfaces. We're going to take a look at point database conversions, and we're going to be looking at the seismic data import tool, and then the seismic data specific conversions job. These are going to cover some main types of data: Seg P1, the old Seg standard, UKOOA, SPS, and the new IOGP P111 format. We're going to take a look at loading standard data. We're going to take a look at loading some non-standard data and ways to work with that data in the streamlined seismic data conversions job.
You can subscribe to these videos from our webinars page, bluemarblegeo.com, or from the Blue Marble YouTube channel. Additionally, you can find out about training opportunities at our training site. Both web addresses are shown on the screen.
So feel free to go to our YouTube channel, watch our videos, like and subscribe for instant notifications when new videos are available. Now, to get right into this, we're going to take a look at seismic data, which is one of our more advanced topics here in the Geographic Calculator. Today's session, we are going to start off at sort of an intermediate to advanced level. If you are brand new to the application, you're probably going to be interested in our Getting Started session, which we recorded back in April. That is available on our webinars archive page and also on our YouTube channel. You should easily be able to find the Getting Started with Geographic Calculator session there. So today we are going to assume that you are generally comfortable with point database conversions, since seismic data is really simply a more advanced spreadsheet style conversion that we would normally see in our point database interface. Just real quick, we're going to take a look at the interfaces, how those interfaces are a little bit different, and then we're going to jump right into it with some actual data. So here we are on the seismic data conversions job. You'll see I've already got a Seg file loaded in. This first piece of data is an example of a Seg P190 file. So the old school seismic data format that's been around for since the 1990 is the standard date there on the data specification. This format is an older standard at this point, but it is still alive and well. There's a lot of legacy data that's out there in the world, and it's still one of the most common formats of seismic data that folks come to us at Blue Marble for help converting. So here on the seismic data job, you'll notice that we have a spreadsheet style interface where we interact with all of the rows and columns in the data file. In the middle of this, we have several columns here. We have 4 columns of a latitude and longitude, and then a easting and northing columns. Those are in columns 5, 6, 7, and 8. Those are standard locations for the coordinate columns to exist in a Seg P1 file, which is what we're looking at here. We'll see some of the other columns in there, like the line name column in the second column, the shot point number in the third column, and then the other columns. There's 15 columns total. They don't all have data in this particular file, but they are all accounted for as placeholders. So one of the first things where seismic data gets a little bit different from our regular point database conversions is that the data is uniformly structured, or theoretically. Sometimes there's variations that we're going to be taking a look at, but in a regular point database conversion, I'm just going to click over to a point database conversion where we have a sort of unstructured Excel sheet loaded in. In this particular file, we have our eastings and northings in the first 2 columns. Those easting and northing, or if we had latitude and longitude, they could be in any place in the date table. They could be in any order, but there's no requirement for something like an Excel sheet for where those columns are specified. And because of that, on the point database conversions job, you'll see we have a column settings button immediately beneath the table for selecting our inputs and outputs of the northings and eastings and latitudes and longitudes, depending on what systems we're working with. Back on the Seismic Data Conversions job, you'll notice we don't have that column settings button. And the reason for that is we know where the coordinate data is already by virtue of the specification for the type of data we're dealing with. So in the case of the seg file that we're looking at here, we know that in columns 5 and 6 are our latitudes and longitudes, and in columns 7 and 8 are our eastings and northings. Depending on the coordinate systems that we specify for input and output, we're going to automatically select which columns are going to contain the inputs and the outputs. So that's the first bit of streamlining that we'll see here in the seismic job. Now, another piece of seismic data that is a little different than some of the other point database jobs is the presence of header rows in the databases. So we have this little header button immediately beneath the table, and if we click that button, you'll see this is a resizable window that comes up. It looks a lot like a text editor window, and that's essentially what this is. Most of these seismic formats have ASCII-based text headers at the beginning, and they usually have standardized entries for the types of information that we see in the headers, everything from the names of the lines to survey company names, the vessels that are involved, the ships that are actually doing some of the work in the case of hydrographic surveys, all of the relevant people that are involved in the survey, and a lot of metadata, things like the instrumentation that's being used, the coordinate systems that are being used, and exactly where in the world this information occupies. Now, in the case of this header, down at the bottom, we can see we've actually got some problems with this data. One of the big tricks with seismic data is that there are a lot of variations used in different pieces of software. These are all ASCII-based text files, and so some of these are not quite as standard as we would hope they are. So part of the initial load process on a piece of seismic data is whether we're going to load these as a standardized format, so if it's going to actually respect all of the normal ins and outs of the data format, or if we're going to actually need to do a little bit of cleanup while we're loading that. And in the case of this file, we actually do need to do a little bit of cleanup. So this is an example of some real data. This seg file that we're looking at came into us as a problem file from a customer years ago. All of the data, all of the line names, everything in this file has actually been changed to scrub it out and make it not proprietary anymore. But this is an example of a real common variation that we see in some of the seismic data that is out there in the world. So specifically, the problem with this data is that we're picking up these first chunk of rows of data rows. These are all shot points in our file, and for some odd reason, they're being recognized as header records, and they're being pulled off into the header area here. So what we're going to do is we're going to reload this data. And to do that, it's just like loading a point database file. Up at the top of the screen, we're going to click the little ellipsis button, and I'm just going to reselect the file that we already have loaded in here. And when we load this, this is the prompt that we're going to be asked for. Do we want to load this using the default scheme for the file type? And there's a simple yes or no choice here. You can always choose one or the other if you don't want to face this dialog. That you might do that if you know all of your data is always adhering to the standard, or if you're a person whose data is always not adhering to the standard, you can choose the other and not have to make the choice. Myself, I usually leave this set to ask me every time, just because I deal with a lot of different types of data, and I suspect that's true for a lot of users. So in this case, I'm going to say no, I'm not going to load this as the standard, and when we do that, it's going to walk us through the load process through our import wizard. So this is going to allow us to inspect the header records for the file, how we recognize those headers. It's going to allow us to govern how we recognize our data records, where our columns go, and various settings like that. So as we step in here in the very beginning here, because I've loaded a seg file, and that is it has the extension .seg at the end of it, it is recognized as a seg P1 file. You'll notice sometimes if you get into adding additional extensions to be recognized, you'll notice that some of these can be picked up as different types, and sometimes you will simply have the wrong extension on a file. That's not uncommon with some of these pieces of data. So you can click the drop down to change the type of file it should be recognized as. In this case, it is closest actually to a seg file, so I'm going to leave it set to that type for input. And then in the bottom portion of the window, it's going to show us a little preview of the data that we're actually looking at. And I'm just going to make that a little bigger so we can see a little more data on screen. So the first bit just shows us the top few rows of that file. I'm going to click Next, and it's going to take us to the header settings. And in this case, this is actually where our file has gone wrong. There are a few different common header types that we have in these seismic data files between the seg formats, the UKOOA formats, and the SPS formats. And in this case, our seg header type normally requires that there is an H on every 20th line. That's what this block length setting is here for. Block length is basically a computer data storage term. A block is a number of rows of the text data that we have, and so in this case, every 20 rows following an H character as the first character of a row, every 20 rows we need another H, and it's going to pick up 20 lines following every H. So I'm fairly familiar with this data file. I know exactly where to look for the problem, and I can see that there is actually an H on every single row of our header file. Now this is a common variant we see with seg files a lot, and the reason for that is that having an H on every single row is the header standard for one of the other formats. In this case, it's the standard for a UKOOA format. So common flip-flop that we see there between those two formats. And what's happening is because we have an H on every single row, we get down to that last line of the header there. In this case, if you're looking at row 67, you'll see an H on that last row as well. And so it's taking row 67 and then the 20 rows following that as one logical block or one piece of data. And so that's the reason this particular chunk is getting peeled off and stuck in the header editor. Now to fix this, I can take a look at my header and I can figure out different ways to describe that. If I had, let's say I had maybe some sporadic H's on there, they weren't in any particular sensible order, or they were just missing completely, I might simply say that the total number of header records in this data file was 67 rows, and then the top chunk of that file would get recognized. You'll see the portion that's highlighted in yellow is what the settings describe in the preview of the file that you're looking at. If there are blank lines, sometimes those can be used. In this case, we don't actually have any blank lines in our data file, and so that doesn't help us. It grabs the whole data file. But what we're going to do here is we're going to say that the header records start with an H, and because there's an H on every single row of our header, I'm going to change that block length to just 1. So it's going to say only recognize the single row that that H is on. And when I do that, that allows us to recognize however many rows there are. And because I'm able to now recognize the H's on every single row, it's also going to clean those up on its way in. It is able to actually peel those off of the front of each row. And in our output, we'll actually be able to place them back on every 20th line with the appropriate placeholders in there. So there's a number of tools in here. You can see the flexibility of just these 3 individual settings, and those are going to be the primary mechanism for cleaning up header data, whether it's here in the seg P1 data that we're looking at, whether it's the UKOOA data that we'll be looking at in just a minute, or an SPS file. So next, on the next screen, we're taking a look at where the data records actually live in the file. Here we're going to take a look at the seg file first because it's a little bit simpler. We're going to come back through here and we're going to take a look at a piece of UKOOA data, and we're going to see some differences in working with this dialog. In this piece of data, our data records are actually cleanly formatted. You'll see all of the red lines, the red vertical lines spacing things out in our data table here. Those are indicating where our column breaks take place. we can interact with each of those columns. So in the case of a seg file, there are 15 columns. There are always 15. If there is no data for a particular column, they are still left there as placeholders. But each of those columns has a given width. It has a justification, left or right, within the particular columns, and we can see where those columns are based on the red separator lines. Now, if you're working with data that does not cleanly follow the normal column line breaks, we can actually click and drag those red column lines to the appropriate place in your data to clean those up. And that will help you realign your data if there is something like a simple offset in the text of all of those given columns. There are cases where you'll need to do a little bit more cleanup if those columns are not uniform from row to row, but this is a very common thing where you might have simply an extra character, or you might have a character shift that's missing in the data table. So I'm not going to mess with our columns on this particular piece because this one actually does respect the normal 15 columns and their normal column spacing. So I'm going to click Finish, and that is going to reload our data into the data table. And now, if I take a look at our header portion, you'll notice as we go down to the bottom of that header that there is no data that's being recognized falsely as header. So all our data is now in the data grid, and the header is separate in its own header area. So the header itself also contains the information, usually, that is relevant to the coordinate transformations and coordinate systems that are involved with the data table structure. So down at the bottom of the header, it's not always at the bottom, but it's very frequently found in the bottom, our coordinate system for the projected systems and the geodetic systems are specified. In this case, there are some things that are a little bit out of standard. It mentions the datum name, and in this data file, originally it did actually specify UTM Zone 38 WGS84 as the datum name. That's not entirely appropriate, but it does give us the part of this that we're interested in, the actual datum. If I wanted to clean this up for our output, I could simply text edit out any of those portions that I was working on. If I was going to be actually changing the projection to put this in a different projection for importing into a project that might have been put into a different coordinate system, you can actually edit all of those fields in there. These are all text editable fields. Unfortunately, the standards for these older formats don't have places for coded entries, and so this is all up to you as the user to go through and make sure that the text of those headers is appropriate and makes sense for the context of your data. So I usually try and clean up any of those little mismatches and things like that I notice, such as the name of the coordinate system being in the datum, or the datum name only being in the projection category, and things such as that. So the edits in there, those are up to the end user to make. Some folks will use this to simply strip the headers off completely if you're just interested in, say, the nav portions of the data. But this is a completely open text-based editor for those header records. Once we've gotten our coordinate system straight, let's say we were going to do some QC on the coordinate systems that we had in place. Our geodetic columns are reported to be WGS84, and our projected columns in C7 and C8 here are reported to be UTM Zone 38 in meters. If we wanted to recreate the transformation that we have in there to go from lat long to our projected system, we would set up a conversion just like we normally would for a point database conversion, except it's actually one step simpler because we don't have to set those columns. Once we import our data, and we use that data import wizard if necessary to line up the columns where they should be, we don't have to actually specify those. All we need to do is set the input and output coordinate systems. So for this data, our input system is going to be WGS84 latitude longitude found in the geodetic folder, and our output system would be UTM Zone 38. So I'm just going to double click on my system box, And in this case, I know exactly what system I'm going for in the UTM group, so I'm going to say no, I don't want to filter these out by geographic area, because in this case I can actually get to it faster by navigating through the full folders. Find zone 38 north, we'll click OK. And we'll see the interface change just a little bit. And this is something that has actually recently changed this year in the calculator. If you're somebody that's been using the seismic data conversions for the last few years, this is an interface change to pay attention to if you're moving up to version 2015, as well as 2015 Service Pack 1 that we're on today. You'll notice a couple of checkboxes light up, and there is a single coordinate system box on the output side. The way this has been for the last couple of years, there were actually two coordinate system groups on the output side. There was a geodetic group that was a subsetting of a projected system. So in the case of this conversion, you would have in the past seen WGS84 UTM zone 38, and then in a different group box immediately below that, you would have seen a separate setting for WGS84 as the geodetic of that. We've simplified this basically to compact the interface just a little bit, and we can still accomplish all of the same settings here. In the case of setting the input could be either the projected or the lat long in the case of our data here. If one of those columns was blanked out and you wanted to recalculate it based on whichever columns you have, you can put either projected or lat long on the input and projected or lat long on the output. If you want to recalculate both of those columns, you simply check off both output projected and output geodetic coordinate system. If you only want one of them, you just simply toggle off whichever one you don't want. So in this case, I just wanted to run a double check on my northings and eastings. I'm going to turn off the output geodetic coordinate system, so it's only going to recalculate columns 7 and 8 over here. Now the one last thing I want to double check is my input format. So you'll notice in C5 and C6 we actually do have the standard formats that are used in the seismic data here, often commonly referred to as packed DMS, where we don't have any spacing, we don't have any decimals. We simply have placeholders to determine which are our degrees, our minutes, and our seconds in the string of numbers there. So I just need to check my input format to make sure that that is actually appropriate on the input side. It looks like on mine I actually might have the wrong coordinate system specified for input. Nope, my mistake there. It looks like we do have packed DMS set as our units coming from our input side. And in the case of our write format, if I was also setting this out to geodetic WGS84, I would need to set that to match up either packed DMS, or if I was looking to convert that to something a little less standard for seg, I maybe could have decimal degrees in there. But in the case of this conversion, I'm not actually outputting to a geodetic system. So my right-hand format doesn't really matter in this case. My right-hand format for my UTM zone, since I'm only working with the linear outputs, I would go to the linear decimal precision on that side and check off how many places after the decimal I wanted to follow through with. And in this case, the default is set to 2, but I want to take that down to 0 because in these columns we actually have no decimals. We are working in whole meters in these two columns, and that's fairly common in some of these data formats as well. So I'm going to go ahead and say OK now that I've cleaned up my formats for input and output. And then lastly, I just need to give this file a place to go down at the bottom. So our output data type, we're going to write this out as a standard seg P1 file. And I just need to give this a place to go. So I'm going to put this out to my desktop just for simplicity's sake. And I'm just going to call this one output seg. So now my output has a place to go. We've set our input and output coordinate systems. We cleaned up the header on the way in, and then we can go ahead and take a quick preview to make sure that the coordinates all convert out as we expect in their appropriate columns. In this case, we're updating C7 and C8. They look pretty good, and so I can go ahead and hit the process button. And what that's going to do is actually write out the entire file. The preview button, as we click that, it just gives us a quick on-screen preview of what we're working with here. And then the process button actually converts the entire data file out as a new file to the location that we've specified in there.
So Sam, can we create permanent variance?
Yeah, so on the data types that we're dealing with here for input and output, on the output file that we just created, we selected the standard Seg P1 output there. And we also selected that as the base standard for our input. Now, if we're working with a lot of data from maybe, say, the same vendor or the same software package, and there's a common variation in there for input and output. Sometimes you either want to have that automatically recognized for input, or you might want to do a whole bunch of these out to a variation for output if you're working with a particular software package that handles a variation a little bit better. So there's actually a setting for this under the Preferences menu. So we're going to go up to Options and Preferences. And in the Preferences menu, you'll see there is a section specific to Seismic Survey. And in that Seismic Survey section, you'll notice that in that drop-down, we can actually add our own formats in there. So we can add new variations to that window. We can base those on copies of the existing standards, and those will all remain persistent in our own installation in our workspace, and you can actually share those with other users. What that will do is build out this list of pre-saved types, and so you could say change the name here to Seg P1 variant if you only have one. Some folks will tag those with a particular name of a particular vendor software or a particular contractor that has delivered some older data that was not quite in the normal standard. And you can easily basically point and click to work your way through that wizard rather than having to define those variations every single time. That list will then populate here in the Preferences dialog. You'll have multiple variants that are permanently stored in there, and that can really facilitate working with some of those variations when you're doing a lot of them for input and output.
What seismic formats are supported?
So in that drop-down that we have here for those formats, you'll see we have 4 of the base types of formats. So what we've been looking at so far is the Seg P1, and specifically that's the 1990 variation of Seg P1, or the most recent variation of the old Seg P1 standard. And that is recognized. You'll see the list of formats that are recognized for each of these in this panel on the right. And so for Seg P1, we recognize the extension .seg by default. Now you'll notice down at the bottom here, there's this Add Extension button. Every once in a while, you'll have files from a particular vendor that might have something else, and a very common one that a lot of folks see for Seg P1, instead of .seg at the extension, they'll have .sp1, and so we can click that Add Extension button, enter in the extension for the files that you're working with, and say OK, and add that to the list. That will then let you recognize in the calculator when loading, it'll let you recognize files that are .seg or .sp1. Or even other variations I've seen on that would be a 5-letter extension, which is a little more uncommon. I've seen files with the full extension .segp1. Sometimes you'll see even the 1990 referenced in there. But the Add Extension button can extend any of these predefined settings to suit what the commonly used formats that you have are. So for Seg P1, right now, out of the box, we simply recognize .seg, and you're free to add your own in there as well. For the UKOOA format that we'll be looking at next, that normally has a default of UKO. Every once in a while, I've seen those as UP1 or P190, whole bunch of different extensions that we might see on those. And again, you can add your own on those. SPS, this is a somewhat lesser used extension called shell processing system. It's just simply another one of the older seismic data formats. That is commonly recognized as .SPS, but again, you can add your own there as well. And then down at the bottom, the new UKOOA, excuse me, not UKOOA, the new IOGP, that's the International Oil and Gas Producers Association. The P111 format, the more recent seismic specifications, those are recognized as a P111 extension. And again, add your own at will. So out of the box, there are 4 recognized extensions, but that is open to the end user to extend as you will to recognize some of those data formats.
Is there a limit to the size of the data?
That's actually probably our #1 question for these interfaces. So those of you that are familiar working with seismic data are probably comfortable with how long these files can actually be. For those of you that might be newer to seismic data, it's not uncommon to see some of these files, particularly the SEG P1 and the UKOOA formats. It's not uncommon to see millions and millions of records in a single one of these files. So these are ASCII text-based files, so millions of records can occupy quite a bit of size. These can be pretty large files. And a very common question is, how big can the file get before we can't handle it anymore? And the simple answer to that is the way we load the data into the seismic data conversions job, there is no upper limit to the size of the data that can be processed through here. What happens when we load the file in is you'll notice that we only load the first 50 records into the data grid. Now this particular file actually has, I believe it's somewhere north of 1,500 records. So this is still a pretty short seg file, but we're not actually loading the whole thing. We're just simply taking in a preview of the top bit of this file. That is also something that is controllable under the seismic data preferences. At the very top of that, you'll see a setting to load the first X number of records into the data grid. So how much of that file are we actually going to preview? The default setting for this is 50 records, and that works pretty well for most folks. If you want to get a longer preview on that, you can put any number you like in there. Some folks like to simply toss in a 0 and load the first 500 records to make sure all the columns are in line for a good chunk of the file. Some folks will actually even put in thousands. The reason we start off with a low number in there is because simply in the terms of loading in a data file of this length, if you're working with 1 million records in here of numeric data, there's no way a pair of human eyeballs can simply visualize all of that for quality purposes. There are error reporting messages that will come up if particular rows in the data are encountered with bad content in them. If they're blank or if they have simply bad data in them, you'll get messages while you're processing that data. But the idea here is we're going to take just the top chunk of that file to visualize it in the data grid. And then as we process in the background, as we actually write that out as its new file, all of the records in the file will be converted over. And a follow-up question on that is typically what type of memory footprint does this actually require? So if we're still loading millions of records, can this be done only on very heavy workstations? And the answer to that is it's a very, very light load. It is comparable, actually, the way we process this. We process one row of the file at a time. So the load on the computer is actually extremely light. It is, to describe it in simple terms, to convert 50 million records in one of these files takes no more memory than it does to take one record and then repeat that process 50 million times. So it's very efficient in terms of its handling. It doesn't require a particularly powerful workstation to complete that on. The only restrictions around any of these data formats are actually your hard drive available storage space. Which on today's workstations is not commonly an issue for too many people. You're only limited by the size of the file you can actually physically store in this process. Okay, so next up we're going to take a look at some UKOOA data, and this is going to be slightly more complicated than the SEG data that we were just looking at a moment ago. Now, UKOOA data is commonly used for hydrographic surveying, or commonly was used for hydrographic surveying in the past. As well, this is a 1990 file specification, so this is another one of those older ASCII-based text files, and most of these are actually going to start being replaced by the newer IOGP P111 format as we go into the future here. But again, just like the SEG data, there's a lot of legacy UKOOA data out there in the world that folks are still needing to work with. Now, UKOOA is just a little bit more complicated than SEG because of the row structure in the data. There are actually two different column structures for different types of rows in the data. So in the case of the data here, we've got a little header problem that we're going to take a look at in just a minute for loading this in. But then you'll notice that there is a particular row here. It's the fourth row. It starts with an R, and that row is shaded in gray, indicating that it is a little different than the rest of the rows that start with S's. So UKOOA data can have receiver records, so those are basically the listening coordinates in the seismic file, and then the S's are the shot point columns. So the shot point columns typically resemble a little bit closer to the seismic data that we see in SEG P1s, where we have our latitudes and longitudes and then northings and eastings. So those go from column 8 and 9 and the projected in columns 10 and 11. But in our receiver records row, we actually have 3 pairs of projected coordinates. So you'll see those in columns 3 and 4, then in columns 7 and 8, and as well in columns 11 and 12. And that is a completely normal part of the UKOOA specification. Sometimes you'll work with UKOOA files that don't actually have receiver rows. Sometimes you'll work with columns that have many receiver rows and no shot points. But these data files tend to be a little bit more differing from file to file with your shots and your receivers. So here we're going to reload this file as well, taking a look at that header setting and also how we recognize the data. So once again, I'm going to say, no, let's not treat this as a standard file. We're going to step into the wizard. So because this is a UKO extension, we're recognizing that as a UKOOA P190. And it's again showing us that preview down at the bottom of the screen. I'm just going to make that a little bigger again so we can see a little better what we're doing. And on the header portion of this, you'll see the standard UKOOA header is recognizing every header record needs to have its own H on there. The UKOOA data actually has coded header records, so there's actually a little more information about what is on specifically each record. But each of these needs to have a standard H on each row. And then in this case, there were some extra placeholders. And in this case, we just added some placeholders in there to be a common example of stuff we see in some data. So we have 3 extra chunks of header row down here that we also need to pick up with our file. Now, we have the H's on each of our rows, and you'll see we have some numbering here to recognize some columns in there as well as just simple placeholders. And then we have these 3 extra placeholders beneath that. Now, if we want to pick those up and recognize those, there's a couple of things that we could do. So again, we could simply specify the total number of header records. I could say there are 36 header records in this file. Because each of these starts with the same word, I could recognize that header records begin with a particular string, and so I might actually say, let's recognize the word this as our header record, and you'll see now every header row that starts with either an H or a this will pick that up, and those will be recognized. The block length again on there is simply 1. Another way to do that would be if I didn't add the word this that is on the start of our header records, I could actually set our block length to 4, and that would strip off all of those H's at the front, and then it would pick up the next 3 rows beneath my last H. So again, there's a few ways to do that, depending on whichever way is simplest to recognize the variation that you're going to see in your own data. So we go next over to the data records, and this is where it gets a little bit more complex in terms of UKOOA data. Now in the SEG specification, there is no difference between a receiver record and a header record. On the UKOOA format, there is a pretty big difference between the receiver records and the UKOOA and the data records. And you'll see a little drop down that lights up, so we can recognize either the receivers or the shot points, and those each start with their own coded letter. So the receiver records start with an R, and the shot points actually start with a number of different letters as possibilities. And in the case of a UKOOA data, T is actually one of its reserved codes there at the start, so it's actually picking up those 3 records of placeholder header. Now in this case, we read the header first, and then we read the shot points and receivers. So the header is peeled off, and in this case we won't need to worry about those columns because those are also being recognized as header. So those will get nicely cleaned off for us still, even though they are being picked up as a possible shot point column. Then the rest of the shot points, you'll notice our 1 receiver row up there is not recognized as a shot point row, but the columns are in totally different places for the lats and longs, northings and eastings, and all of those other 15 columns between the shot points and the receivers. So there's 2 different sets of column structures in there. This is one of the things that is handy about the seismic data conversions in particular relating to UKOOA data. In previous versions, years ago of the Geographic Calculator, before we supported seismic data job specifically, it was a little bit tricky to handle both the shot points and receivers in a single pass. It would actually take multiple passes on the data, and it would have to be separated out to do this. With the advent of the Seismic Survey Conversions job, we're now able to do this all in a single pass with both coordinate systems at once. So cleaning up our header and checking out our data columns, everything looks good in there. I'm going to go ahead and say finish, and that's going to reload my data into the grid. Again, recognizing my receiver row and shading any receiver rows that it finds within the data, shading those gray, and then all of the shot point rows showing up in the regular white background, each being respected with their own columns. Now the coordinate conversion portions of this happen exactly the same in terms of the input and the output systems. We can have either a projected or geodetic system for input, or a geodetic or projected system for output. If you do pick the projected output, again, you will have the choice of which of those to include with your conversions. Sometimes folks are only interested in changing the projected systems in these. Sometimes they're only interested in changing the output geodetic system, but you're free to make that choice for the data that you're working with. I'm not going to bother stepping through the actual conversion for this, since the process is exactly like we just looked at on the SEG format. The only difference here is in how those columns are actually read and how the rows are recognized between the receivers and the shot points. It has exactly the same data handling capabilities, so millions and millions of conversions can be supported in here. And what we're going to take a look at next is a little bit of a change in gears in the seismic data conversion for the newer data format of the IOGP P111 specification. So I'm clicking over to a new job here, and we're going to see this one looks quite a bit different with some shading that we see in the data grid. Now, the new IOGP P111 standard is not widely in use. This is something that the industry is pushing forward among seismic survey firms that are out there doing this work. This data file that we have is actually a sample file that comes along with the specification for this data. And this is a drastically different format from the older data storage mechanisms for SEG and UKOOA. The IOGP P111 format is a lot more flexible, and it's actually been created to be a replacement for both the older UKOOA format and the older SEG format as well. So it's capable of handling both types of data, and it has some drastically different structures that we see in there. So when we load a P111 file, you'll notice the header button completely disappears. And this is one of the major differences between the modern P111 format and those older formats. It is still an ASCII-based file, but it is both easier to read natively and a little bit easier to work with because it actually supports various coded entries, so codes for all the various coordinate systems and units and all of the bits and pieces of the geodetics in there. You'll notice within the records that we're looking at right here, each of these records begins with an HC. That is one of their codes to recognize a comment, or rather a header comment record in there. Those are telling us the various things that we're looking at here, all of the various units of measure that are defined within this particular file. As we scroll down through there, you'll see there is a lot of different information about the coordinate systems, all of the various EPSG codes for the systems that are involved, the units that are involved. For both horizontal and vertical coordinate systems. You'll see this actually specifies the geoid for the elevations that are in there as well. The CC column in here, or rather, excuse me, the CC row that we see in the table, that is actually a comments row, and that is basically extra free text that can be inserted in these rows. Getting down into the data, there's a lot of header attached to this file. So for this particular one, this is a good case for where we might want to increase the number of rows that we load in from the data file. So I'm actually going to up our loading in there for the preview. I'm going to say go ahead and load the first 500 rows on there. I'll just quickly toss our P111 back into the grid. And then we'll see as we get down far enough, there's a lot of header information in there, and eventually we'll get down into the actual data within there, so the individual shot points that are in there. Now the handy thing about the flexible structure of the modern format, the P111 format, is that we can actually have comments interspersed throughout the data. So this is a very, very flexible format, and in this one it explicitly tells us that we have arrived at the beginning of the land shots for this chunk of the data. And as we scroll down through there, you might actually see more comments interspersed there telling us what those points are. Now in the case of the older formats, if we had blank rows or just random comments spaced throughout there, those could actually cause some problems in the conversions. But the newer format is actually structured to support that kind of extra metadata throughout the file. So again, this is a format that's going to be increasing in popularity. We've heard from a number of seismic data providers, the actual survey contractors out there, that this format is going to be starting to be used much more frequently for new survey work that's going out there. So it's ready and waiting right here in the conversions interface. Exactly the same capabilities in terms of the input and output coordinate systems, but there's actually even that one easier step of not having to handle the header information because of the way it's been structured. It can now be completely automatically recognized in the data format, and because it uses all of these coded entries with standard EPSG code names for the units and the systems that are involved, it's actually all automatically handled and updated as coordinate data is transformed or converted inside this data file type.
Sam, can these seismic survey conversions be batch processed the way other jobs can be?
Yes, they sure can. So all of these data types that we've looked at here, all of these can actually be executed in a batch process. So I have a few of these saved right here. So the seismic conversion that we started on, I've saved these in my workspace. This is my common demo workspace as saved templates. But let's say, for example, somebody gave me a whole swath of seismic data. Let's say we had some more seg files that had similar coordinate systems. Maybe these were some of the different lines within a given survey area. If we needed to replicate the same conversion across a whole batch of these, the batch works exactly the same way as it does for all of the other conversions that we see in the calculator. We set up one job as a template, so I could use this first job as a template, and then we simply right-click on that, and you'll see a batch add setting at the very bottom of that context menu. When we click on batch add, this is going to take you to our standard layout for our batch dialog, where we add however many input files as we want for our batch. This can be up to thousands of files in one go. Usually for seismic projects, this tends to be a few hundred at a time for a given project area, up to a few hundred. But if you say you have thousands that we need to do a similar conversion on, can go up into the thousands of these easily. The coordinate system settings, you'll see they're all displayed there for you, but they're all grayed out because this actually comes right from your template job. And the only thing you need to specify is the input files that we're going to run in there, and then any naming that you want to apply for the output files. So we can add prefixes or suffixes to any of those original input file names. Whether or not you want to output these as any of the default schemes or any of your variant schemes that you've saved permanently in there. And then just like any other batch, we would generate that batch, and you would see a new batch project open up in your project manager. And that gives you the ability to save these in a workspace if you're going to be working on a workspace for setting up different types of projects. You want to run them all. Maybe you want to run a batch of them over the weekend. You want to group several batches together in a very large project. Those work through the project manager exactly like any other batch, whether it's vector data or point database conversion or raster data. And for a little more information, if you're new to batching, batching would be covered in some of our other webinars, including our Getting Started sessions. So again, just like any other batch, all the same capabilities there in terms of seismic data.
What if the data is extremely different from the standard file format?
Okay, so we've talked a little bit about what happens if your columns or your headers are just a little bit out of whack. What we can do to clean those up, recognizing them as something that is similar enough to the standard seismic data formats, 15 columns, lats and longs, northings and eastings, all in the same relative place. This is where it can go really off the rails. There's a lot of data out there that people have modified, messed with, text edited into non-uniform things. And this is where a really advanced user can clean stuff up with a little more powerful knowledge of working in the point database conversions. So I'm just going to steer you into where to look for this. And I'll point you at some of the other sessions that we have on our YouTube channel for point database work in there to get into some of these. So for example, here in this seg file, we had data that cleanly aligned to these columns, and the columns were all in the appropriate order. One of the sort of historical things in here for longtime calculator users is that we used to handle all of the seismic data as a point database job conversion. So these all of the seismic types used to be handled in here, where you had to specify your headers, you had to specify which columns were your inputs and outputs using that column settings button on the point database conversions job. For every single type. There was no standard recognition of the seismic types for where their columns were. other than simply loading them up as a recognized input. You still had to completely explicitly define all of the inputs in the output columns every single time. You can still actually do that in the point database job. So the jumping off point for this is if you've got a file that is really out of whack, if you have nowhere near the appropriate 15 columns, or maybe you have files that have been extracted from true seismic data. We see a lot of data that has simply been extracted out into just the northings and eastings for folks that are looking to plot the nav of any of these files. You'll notice on the input file types when loading point database jobs, under the recognized file types, you'll notice we still have those seismic data formats supported on the point database job. And when we load those types in there, let me just grab onto my Seg P1 file there. When we load those files in there, you are completely free to reorder the columns, restructure them in any way. We can do drag and drop to reorder those columns around. We have full control over the column settings for specifying our inputs and our output coordinate systems. But you can use the point database job with its slightly more complicated setup. You can use that point database job to really change around the structure of data that's not quite close enough to the seismic standards to bring that in there. You can actually fully do your coordinate conversions on the point database conversions job to clean these up. And it would still be for best practices. In most of the cases, you're going to have an easier time loading these files on the seismic data job and working with them there. But if you've got some data that has really been altered away from the standard seismic data specs, you can use the extra flexibility of the point database conversions to clean some of those data files up. So that is pretty much going to wrap it up for the topics we were going to cover today. We're always taking new questions and recommendations from users like you for topics that you would like to see in the future for our webinars. So I would like to just put it out there if you have any further questions about stuff you've seen in our webinars, or if you have any questions that you would like to see handled in upcoming topics. We do post our upcoming topics on our webinars page on our website. You can send any of those questions into geohelp@bluemarblegeo.com. That goes directly to our tech support team here at Blue Marble. And Jasmine and I both work with our support group as well as some of the other hosts you'll see on our webinar sessions here. So feel free to get in touch with us at geohelp@bluemarblegeo.com for any questions you might have about this session or other sessions or things you'd like to see in upcoming sessions. Again, our full archive of these sessions is available on our YouTube channel. So if you want to get instant notifications when we post new videos, feel free to subscribe to our YouTube channel. Like it to let us know that you're a fan. Post comments, questions there as well. I'd like to thank Jasmine for joining me here today. And thanks everyone for listening, and we'll see you next time.